Exactly. Exactly. I feel that pain. It's like, I'm here to, well, we got a sort of a problem, a little technical difficulty. Jduck, obviously, I'm not supposed to speak right now. It's like Jduck is supposed to be up on stage, and he's a little nervous right now. And I mean, y'all might want to help him because I think he's got a really bad case of stage fright. So if y'all can just give a good round of applause and try to get him up there, that'd be awesome. There you go, jduck.
All right, this is what I needed. Thank you, Jason. I didn't set up, though. We had to, like, not set up to do that joke. I'm hoping I fare better than some of us have so far on getting this to work. I don't get it. The window I was using totally disappeared. Oh, it's over there. Perfect place for it. One of these buttons does it. Not that one. Let's try that one again. Let's do this way. Yeah, that one right there. That's the button I wanted. Oh. Why does it always want to make that one the most important screen real quick? Yeah. It's like you have this giant resolution display. You probably want that one to be your external one. Oh, wait, that's not your external one. Come on. I fail so bad. Sorry, guys. And gals, if there are any. Well, I can't see anything, so I'm going to have to do it this way, but it's cool. Is this what you call really full screen? I don't think so. Totally not full screen. Who knows the Chrome full screen thing? This menu button over here? No. I just need to get rid of this stupid ass bullshit up here. F11, that's what I thought, and that one is the one that made it disappear. Maybe if I pour beer on it, it'll be better. Yeah, I got a whole menu bar to go away. I swear I've presented this before on the same computer and not had this problem. Let's try this. Okay, that worked. All right, let's do it over here, though. It's F. Just F. All right, so, shall we? I think you guys all know where you are now, and I'm here too. Let's do this. Quick introduction. My name is Joshua Drake, or jduck. At least I go by jduck on the internet. This is a little bit about me. Done my own research for a long, long time. First following in others' footsteps and then paving some of my own path. I work with Imperium, and we wrote this book, me and 5 other guys, called Android Hacker's Handbook. If you haven't seen that, check it out. And I founded the DroidSec research group a few years ago. That's a good hoot every day. I love it. So the motivations for this research, number one, I wanted to improve the overall security of mobile, right? Like, I feel like not enough people are doing that. At least I did when I started this. Increase visibility of risky code in Android, right? There's tons of code in Android. It's ridiculous. Why not point at the code that's particularly bad? You guys have water or only hot ice? All right. So, and I wanted to put the Droid Army to good use. For those of you who don't know what the Droid Army is, thank you, sir. That is a cluster of Android devices always on, connected to USB. If you want to like run some commands on all of them, we can do it on my phone after this. Really fun. Uh-oh, I'm pushing the wrong buttons. So sponsors of this work were obviously Zimperium, where I work now, but also Optiv before them, who were Occupant when I worked there. So they were immensely supportive in when I was doing the research. This is a rare case where the research that I'm presenting here spawned multiple jobs, and they actually allowed me to take it forward. Amir is not here, and these other guys are not here, but I give them a lot of credit because I definitely stood on the shoulders of giants and had some fun with those guys as well, of course. So if you see me keep going like this to these slides that are too early, it's because of like this presentation framework. Like if you hit the right arrow, it's like next section, not next slide. So what is Stagefright? Does anybody not know what Stagefright is at this point? Like, what is Stagefright to you though, Peter? Well, that was kind, but I don't think that I can take credit for that. This is Android's multimedia framework. So any like sort of thing with audio or video, it goes through this library in Android, and it's been that way since quite a long time. You can see down here, like Dan Kaminsky says, like that moment when the name of your product is literally worse than anything anyone else could come up with for the vulns in it. So brief history, like Android originally launched back in the day after being completely closed for a very long time after acquisition with a library called OpenCore. At some point along the way, around 2.0 timeframe for Android, they started developing this other library called Stagefright. They had it optional in 2.2, and in 2.3 and later, it's been default. So 2.3, I'm not sure how many people use Android on a daily basis. Yeah, that's nice. It's like almost everyone. But I got an iPhone now, so beware. So not because of this work, just, do some more work. It's also used by Firefox and Firefox OS. They randomly decided for some reason to pull code out of Android and throw it into Firefox. It's funny too because I reported the bugs to them, and they were like, yeah, we really want to get rid of this code. And I was like, why don't you just do it? So they use it on OS X, they use it on Windows, and they use it on Android and Firefox. They do not use it on Linux. They use like GStreamer, which, I don't know, maybe that's bad. I'm not sure. All right, now I'm jumping all over the place. This is terrible. So why? Let's start with the name of the library, Stagefright. What the fuck? You're like, look at all these directories. There's tons of them. What? Stagefright? That's weird. Who would do that, What's that supposed to mean? These guys have code they're afraid to show people? Is that what they're trying to say? So, also, it's exposed with multiple vectors. It's like, yeah, that's pretty cool. I'll talk a little bit more later about the media scanner. The media scanner is basically like aggressive AV style, scan all the things, especially the ones that are untrusted. It's scary. It's binary, it's written in C++, so, there's a lot of potential for mistakes there, and not only that, but the file formats are binary, meaning they're complicated, there's a lot of numbers in there, you gotta be very careful. Even worse, like if you go look for Android crashing all the time, then you'll find like people talking about, like my battery's really bad, and when I look at Logcat, it's like just spewing of how it's crashing every time it's reading some file. Yeah, so that's kind of like perks the eye, you know. That's the one eye up, maybe not both eyes, but. And then there's some related publications recently. So I'm certainly not the only person that can do this work. These guys, I believe this is the one from Intel. Okay, yeah. So these guys did a talk in April at the Android Builders Summit about fuzzing the media framework in Android. It was a great talk. They released their own fuzzer, so you can totally run their fuzzer if you want to. And they say in their talk that they submitted 11 terabytes of media files to the Android security team. I'm not quite sure how you do that, but they did that. And I was like, that's a lot of data. I couldn't really say anything more than that. But that resulted in 7 security issues that they said that, you know, they were like 7 of them they cared about. And then 3 of them is all I ever saw get fixed in EOSP. These are the CB numbers. We'll talk about them a little bit more later. So designing efficient distributed black box fuzzing. These guys did a talk completely unrelated to Stagefright, although Stagefright was kind of one of their test cases, or media files in Android were one of their test cases. And I'm pretty sure they got some zero-day in there, but they don't maybe understand it fully. So this is not related or not new, but this is like one of the first Android talks ever made was Charlie Miller at ShmooCon saying, you know, I can defeat John Connor. So his work was based on OpenCore, which was the engine at the time. Actually, his research was so early in Android, in this case, that he had a phone that was a developer phone that he bought off eBay that some developer who worked at Android was selling. They weren't released yet. They were about to be released. All right, so, well, I don't think we need to do that one, do we? No. Oh yeah, last note there. This research here in this slide deck is focused on the MPEG-4 file format. I limited myself specifically to various things just to make sure I would be, to have a better chance of success, right? You don't want to be like, well, I have this web browser, I want to fuzz the web browser, so what am I going to do? I'm going to fuzz all the formats it supports all at once. Well, that may or may not be a great path to bugs. Definitely explodes your state space that you have to explore in a fuzzer. All right, so this is this awesome diagram. This is a newfangled one. They released this diagram around the time of Google I/O this year. So the thing I thought was weird was, why are they calling out media server and system server specifically? There's plenty of things they could put there. But I was surprised by that change. But I think it's much prettier than the one that we've all seen before, if anyone has. How many even do, who knows what I'm talking about, the old diagram? Yeah, it's pretty ugly. All right, so it has lots of inter-process communications going on Android. Basically, every process on Android has multiple threads, and those several of the threads in each process are all just waiting for something to happen externally to them. Waiting for the kernel or waiting for the binder driver to tell them, like, hey, somebody said you should do something. So the sandbox in Android, for those of you not familiar, relies on user-based sandboxing. So every app that's installed has a separate user ID. Every sort of background service that runs has a separate user ID. They're really good about applying privilege of least, what is it, how do you say it? Principle of least privilege. That's the one, right? They're pretty good about that, and they always have from the start. So the thing you really need to know about this is that libstagefright lives in media server, and you know that's not, libstagefright is not in their list there. But you'll notice some important things like audio, which I guess that kind of makes for a phone that's supposed to ring sometimes, the audio thing kind of important. So media server runs in the background all the time. It starts up very early in boot. You can see the process ID here. What is it? I can't see the number, 181 or something. It's really low, yeah. And then it started from init, and even though Android's init is like some totally new implementation of how to bootstrap a machine up, it still does what you would expect in that it's starting services and it automatically restarts them whenever they disappear. Currently, restarting this service is pegged at a minimum of 5 seconds between starts. So if you start it and crash it, you won't get one again for 5 seconds. but if you wait like 6 seconds and crash it, you'll get one right away. So, it's like limited by start time. All right. So on a Nexus 5, you can see the privileges. It's like, user media, group media. Oh, by the way, I want to do all these things that are like maybe, not sort of normal for an app even. Audio group, you cannot get the audio group unless basically you are the audio drivers. You can't get the camera group. They used to be able to. You used to be able to ask for the camera group, and they actually removed like all of that some time ago. So you can't even ask for that. But the point being is like, this is not a, when you think of isolation and putting some code off in some process, you think, well, I'm going to give it as little privileges as possible. Well, this maybe is as little privileges as possible, but they're really awesome privileges, right? Like, oh, hey, I might take a picture, like listen to your microphone, and by the way, I have internet access, so I'll just go ahead and send all that data back to me right away. So it's really kind of scary what you can get out of media server as far as like a privilege level. Oh, I cannot see this picture. Okay. So this is a breakdown of the devices I was testing with Stagefright. I kind of grouped them here by vendor, so you can see the device I was testing. Excuse me. At the time, like most of them were Nexus devices. My point in focusing on Nexus devices was that if you find vulns in Nexus devices, they affect everything. Because in Android, people add stuff to Android, but they usually do not take things out. Okay, so a survey of the privileges. So Android is like an ecosystem where all the devices are somewhat unique. And so different devices give you different privileges in media server. The thing I showed before here with all the privileges, that's a Nexus device. So that's kind of like the baseline. And then this is more of like an indication of the devices that I had. The point being here is can you see, let's see. No, same old stuff here. Let's go to the next one. All right. And so this is like the top of the groups. The way this table is generated is like I said, break all the groups into like sort of a unique, I think I just grepped like with -C for each one of these things and an output from get the privileges for media server for all devices that I had. And so, you see 51 had that group, but only certain ones had these groups. These are kind of the outliers. And the most awesome thing is that you can see that some of these devices, 27 of them, will give you the system group if you compromise the service. So the system group is kind of important. It owns the directory where all writable user data lives, which is basically all the things. And it's the things that get wiped when you use factory reset. Yeah, so, all right, I think that's it for that one. Let's talk about the attack surface. What do you do to locate the attack surface? Like, it's doing something complicated because it's playing video. Video is not a very simple thing. So what do? You just attach to the media server process with a debugger. You put a breakpoint on the open system call because you're like, if you're going to play a video, you probably need to open that video, right? At some point. And so whenever that hits, you just look at the backtrace and just start digging in. So here's sort of a backtrace from the open system call, and you can see all the functions that are being executed on the way there through Stagefright and some other libraries even. Yeah, so interesting point at the bottom. This code is a little bit weird to track when you look in the AOSP Git repositories because at some point they decided to move it out of framework base into sort of its own repository called frameworks AV. So when you look back at the parent functions, you start getting closer and closer to the functions that are actually in libstagefright. And then when you get there, you're at read metadata, which calls parse junk. So parse junk is like the like main dispatcher function for all pieces of an MP4 file. For those not familiar, an MP4 file is like a tag length data format. So it's basically just like 4 bytes, and then whatever data is there. So this function is doing all that parsing, and it's a recursive function, which is kind of interesting and different from a sort of modern standpoint. And you can see here there's an example where it's like, well, if it's an MOV or if it's TRAK, then we're going to go ahead and call myself with different offsets and stuff. Funny point there, like between 80 and 140, depending on Android version, tags supported from the MP4 files. I think 80 was like a number I pulled out of 2.3, and 140 is like number pulled out of 5 dot something or other. So they've clearly been developing this over time still. So attack vectors, attack surface is like what you want to look at. Attack vectors is kind of how you get there. So once you know about the attack surface, it's usually pretty easy to do a sequence of tree greps to see where calls go in, and you just keep kind of, hey, this function reaches there eventually, so who calls that, and then this, who calls that one. You just keep doing that. There's actually like several slides, bonus slides in this deck, if you're interested in kind of walking through the whole process of tracking back the attack surface. But the basic methodology is like, who calls what. Keep doing that until you get tired. So in Android, everything is very modular as well. And when you do a bunch of research with Media Scanner and Stagefright, you end up in weird situations where, like you have Java code that's calling native code, that's calling Java code, that's calling native code, that's calling a service over a service endpoint, and then it's like more Java and native code all mixed together. So it can get kind of wild looking at that. Object-oriented code can definitely be wild with the use of member variables and where those get initialized and stuff. Luckily, Stagefright is open source, so that makes things a lot easier as far as reading it. But another point, like some vectors might be closed source in this case. Google Hangouts is totally closed source, but it definitely calls into Stagefright. So yeah, even though there's pain points with executing this methodology, it's still probably the best methodology for figuring out attack surface. It's much better than trying to figure out by manual guessing which ones would work. How can I play the file over and over again? So this is showing a video loaded into a browser coming from a URL. So that's pretty easy attack vector. You can also force the browser to download a file pretty easily. Basically just declare that it's content type of attachment, or a content type with a disposition of attachment. No, it's content disposition is attachment. So if you do that, Android will be like, okay, I'll just download it automatically and put it in my downloads folder. Well, it just so happens that after it's done downloading it, it will also scan it with the media scanner. So, both ways, it's scanning it every time. When you play it, scanning it. When you download it, it's scanning it. There's no prompting. I totally have a feature request for them, like let me say whether or not I want to download something before you download it and then scan it. That's not very nice. So I mentioned Media Scanner before. Media Scanner is a documented feature in Android. You can read about it. I don't know, there's no URL here, but if you just Google for Media Scanner, you'll find it. It extracts metadata from media with the idea that it's going to take that metadata and put it into like a SQLite database that's exposed through a content provider. That way, when the gallery app pops up, it already knows about what all is there on your device. And so it's pretty important to have this for usability, but maybe not to go as far as they do with processing, I guess. You see here media mount, media scanner, scan file. Media mounted is obviously, well, not obviously, but media mounted is when you shove an SD card in a device, for example, The system mounts it automatically, and it goes, hey, everybody, there's new stuff. And this guy really actually cares about when that happens, because otherwise, you put in an SD card, you don't see the pictures on your SD card because nothing ever looked to see if there were any pictures there. So definitely an attack vector there. So we keep trying this. There are other ones. So I at one point along the way in the research realized that if I sent myself a video over MMS, that it would just parse it with Stagefright right away before notifying me, before any sound happens, before anything, and that scared the living shit out of me, honestly. So there's still client-side browser downloads. Like I mentioned before, you can reach this code through email, although that's usually going to require you to actively get the user to download some attachment. Android doesn't download the attachment itself automatically without you doing something first in email. So there's also other stuff like NFC or Bluetooth or sending each other like virtual cards of yourself. Physical stuff, like I mentioned, the SD card, but also USB over MTP. So that's the default mode in Android for USB since I think 4.0. Before that, it was like some really weird stuff where it was USB mass storage, and it was odd. They didn't like that. I didn't like that. But anyway, like if you copy a file over MTP to the device, it scans it after it's done. Thank you for scanning all the things. 11 plus attack vectors. Some of them I did not count, like if you take a picture with your camera and it saves it to disk, it's also going to scan it, although it's, unless you take a picture of a really cool thing that produces some sort of malformed MPEG-4, it's not going to work. So the scariest part, obviously, is MMS. I totally freaked out. I sent myself an MPEG-4 video after I saw that it rendered in the thing automatically. I sent myself a file that just caused one of the assertions, one of the many crappy assertions in Stagefright code, which it just does a check, and if the check fails, it crashes itself on purpose. So I sent that to myself over the carrier network just to make sure, it's not really it's not an exploit. I'm not really violating terms of service. Sent it to myself. And sure enough, Logcat running, thing crashes before, I didn't even touch my device. It's sitting over there on the table. It's definitely scary. So the nice thing is, after publishing this research at Black Hat and bringing it to the community, the Android security team and Android developers removed the automatic processing of media from both their Hangouts app and 4.1, I think, and also like from the messaging app, which is kind of like their new incarnation of the old one that was AOSP messaging app. And so, it's one thing to do like parsing of like crappy stuff with crappy code. It's another thing to do it with high privileges. And definitely it's another thing to do it automatically. And so that's freaky. So where does it work? Where did it work, at least? It worked on all devices 5.0 plus right away because Hangouts was the default. Hangouts is supported on Android devices going all the way back to 4.0. So anything before that won't run Hangouts. But even with Messenger, even with messaging, the original one, it was still vulnerable to the point where, like, if I sent myself an MMS that was the bad guy MMS, every time that was rendered in any way on the screen would immediately like trigger the vulnerability. So that means like if you have auto rotate on the screen and you turn your screen, that triggers the vuln again. If you try to delete the MMS, that triggers the vuln again. If you turn your screen off and you turn it back on again, yeah, guess what? It triggers the vuln again. Seriously, all the time. So, in fact, I don't think when you try to delete it and it triggers it, I don't even think it deletes it. It's just like, I tried to delete it, but now it crashed already, so. Yeah, so if you haven't turned auto retrieve off, but it's not as important now since they have fixed the apps in newer versions. I'm actually willing to take like a poll or like what do you call that when you're like all betting together on something? Did I get it right where I said poll? Is that bad? A pool. Okay, there. So we take like a betting pool on like how long it takes them to turn this back on after they get comfortable again. Because they definitely like their pictures of cats before you actually have to touch something. I know I miss it a little bit, but I don't use MMS that much, so I wonder why. So I already covered that. Triggers virally. If you touch the video, it again triggers a vuln. If you open the gallery, like, oh, yep, there we go again. So it's really viral, and it's that alone is freaky to me. Very scary. So are there any other vectors? I didn't even like really explore fully all the vectors. I'm like, MMS, that's good enough. I don't need to worry about any of these other vectors. I'm pretty sure you can send yourself like malicious media with a Hangouts message, like, gtalk or whatever they call it these days. I'm pretty sure that works. There was some good stuff coming out after the vulnerability was initially published, that some stuff, like I think, was it Tech Secure or something, they actually won't automatically render the media, and when you like click the media, it's like, are you sure you want to click the media because you might just get owned? And it was like that before I published any of this stuff, so good for them on that one. But there could be more, like instant messaging, QR code, like who knows, right? It could be any of that. Next one. So how did I find these bugs? Is anybody curious about how I found these bugs? Yeah? Does anybody know how I found them? Anybody want to take a guess how I found them? The cotton candy approach. The bugs must be stuck to the side, so I'll just scrape them off. So I basically use this methodology. This is a methodology I stand by, like for all projects. You write a fuzzer, a really dumb one, doesn't have to be good. Just get the automation going. Let it spin while you read more. Like read more and understand more. And the more you read, the more you understand. Like for example, when you find out about the parse junk function and you see all the tags there, you're like, hey, I can make all the tags like hit one of these things randomly instead of just going to the default case where it does nothing. So that's a good example. Like as you keep going, you make the fuzzer better. Eventually, like fuzzer finds crashes. Then you go read that code, because that code probably is even better to read than the code you were reading to figure out how to make your fuzzer better. And you just repeat until your brain melts. I mean, seriously. Maybe it takes a day, maybe it takes more than one day, maybe you're insane and you go for 48 hours straight. But at some point your brain will melt. So, So I did this sort of in 2 rounds, the research as well as the disclosure. The first round of research was Amir and I. We decided we were going to fuzz some MP4s on some Androids. That was literally like the name of our project. Let's fuzz some MP4s on some Androids. I learned that there's a button. Apple has this cool button, but it's not working. I was asking on Twitter, like, how do you make the desktop appear? And I was like, oh, wow, there's a button that looks like that's what it does. The whole point of the button is that. It's cool. But I was going to show you something, but I can't figure out how to get this damn screen out of the way. So the first time we fuzzed some stuff, it was really dumb fuzzer. We didn't really bother with building a huge corpus. Our goal was kind of like, let's find the smallest file we can find, literally like the smallest one. Yeah, okay. So that's the meow one. If you've seen any of the cat pictures of this work, then that's the one. You guys saw it in the browser before. That's his video that we used. We used that for testing tons. So we both ran the fuzzer that we put together on, a set of devices. My set was like maybe 4 devices. His set was like 4 devices. And then at the end of like about a week, we started analyzing all the crashes to see what they were. It turned out like all the crashes we hit during that fuzzing round were all like just terrible, terrible crashes. Usually just assertions. This code is really awful in that they do all these checks, but then they just crash themselves and the checks fail. So that's not very robust, and clearly indicates maybe some hurried development. So it wasn't really fruitful fuzzing, but however, when I started looking at the actual crashes, even though it was crashing on crappy lines of code that were not interesting, I started looking at those functions that it was crashing in, and then I found several integer overflows. So these became these two CVEs down here back when I first found them. And like literally it was like 3 to 4 lines away from where it crashed on some crappy crash. It was like really bad mistake. So the next iteration, I used this excellent tool called American Fuzzy Lop. I was like, hey, I already know about these bugs in Stagefright. How about we point AFL at Stagefright and see what happens? And what happened was, AFL was created to use automated feedback through code coverage in order to build a corpus like that. It's not meant to be a fuzzer to find bugs, although it just happens to do that. It's meant to build lots of inputs that reach unique paths in the program. That's interesting. So the second round methodology was basically the same thing as the first, except for now I was like, I'm running this fuzzer, it's finding crashes like mad, so I'll stop it every once in a while and look at all the crashes, triage them, look at the code it's crashing in, and then I would just, fix the bug because I have the source, so why not fix the bug? So I fixed the bug, start the fuzzer again, and just keep doing that until basically there were no more crashes. And that took about, maybe 2 or 3 weeks in the second round. It was me cycling and fixing things. Yeah, there we go. So I tried all kinds of different modes of AFL as different modes. I tried one where I have a dictionary that was all the MP4 tags that found bugs that all the other ways that I tried to run it before that didn't find bugs. So definitely experiment with all the different modes if you play with AFL, which I highly recommend if you want to find any bugs in just about anything. It's a very disruptive tool for vuln discovery. So yeah, I got about 3,200 tests per second when I ran it on my 32 core box. It was super fast, and that's why I could get away with running it for only like a day or two, because it kind of like keeps track of CPU time and it multiplies it out. You run it for like three days on this box with 32 tests per second, and it tells you it actually ran for like 6 months of what you would normally consider CPU time. So that's awesome. So and the end result is in the second round I found even more bugs that I didn't find before, which was awesome, and because I basically didn't have to do a lot of work to find those bugs. And it also shows that AFL finds good bugs as opposed to the dumb fuzzer, which found crappy crashes that were close to bugs but not bugs themselves. So yeah, and plenty more or less severe bugs, of course. Those are all falling out all over the place. I mean, personally, I consider one of those crashes that's an assertion to be bad, even though it's not really necessarily a security problem. It's definitely not going to give you a shell, but still your audio is going to drop for up to 5 seconds, or it could get worse than that, obviously. Media server crashes and doesn't come back, then, or if it gets stuck, for example, then your device will brick. Like, you'll think, what's going on with my phone? It's like screen won't come on, screen won't go off. Like, media server is a big deal. During my research, I put an infinite loop at the entry point of media server so I could attach to it early. And I rebooted my device, forgot about how I had this in place, and it did not boot all the way. Yeah, it got stuck waiting for media server on that nice little animation right before you see your home screen. So that was fun to try to fix, especially because I had like SU disabled while it's booting. I'm like, now what? So here's a bug summary. All in all, like, let's see, like, what's that, 10? Is that 10? Yeah, that's 10. And beyond this, like, when I disclosed these to Google, it was like well, here's these patches for things that are really important, and then here's this pile of patches that fixes all the shit I think is important, but not as security related. You know, it's just like stability enhancements. All in all, I sent them well over 120 different changes to Android in the first disclosure. I was just like, here you guys go. Okay, so I mentioned before those CVEs that the Intel guys got credit for and were fixed in AOSP. These are these 3 bug numbers, and this is the commit message for the fixes. Well, it turns out, here's the diff. They were like, okay, well, you know, there's an integer overflow down here when you try to multiply the size of a UN32 with some stuff. Oh, well, that comes out of the file. And they're like, well, you know, if we do the same thing, if we do this math and store it in the 64-bit integer, no integer overflow will occur. We will detect that it's too large, larger than a 32-bit possible value, and then we will say, you know, error. Well, it turns out that when you multiply multiple 32-bit numbers over here, right, what happens is, even though this is 64-bit, it multiplies them all out, takes the result of that, then makes it 64-bit. So that was a horrible mistake. I actually saw this code and thought, oh, wow, they fixed some bugs right in this code where I found some bugs. And then when I ran AFL in my second round, it kept finding this, and I kept going, what the hell are they doing? Why does it keep finding this? What's wrong? I look at the assembly, and then I'm like, I see, yes. So that did not fix anything, even though it looks like it fixed something. And here's a quote from you know, one of the wizards out there in C programming. He says, in C, on the other hand, if you multiply these 32-bit numbers, you get a 32-bit number again, and you lose the upper half anyway, which is exactly the same what happens with an integer overflow. So that check actually did nothing at all. It just made an integer overflow occur twice, once for the check and once for the owning. So we got that one. Yeah, so anyway, that's embarrassing but educational, right? Like, this is a very weird quirk, for sure. And, you know, C and C++ are full of weird quirks like that. You know, Halvar Flake said one time to me, he's like, you know, if you want to find vulns, just open the C spec and search for the word undefined, and then understand that, and then go, you know, apply that to the code, and you'll find tons of stuff. And it's absolutely true. So exploitability, can these things really be exploited? I mean, I guess it's not really a mystery at this point whether or not these things can be exploited. A lot of them resulted in memory corruption in the heap. It turns out, you know, there's not really like heap cookies in Android. There's not really like a lot of hardening for the heap. So this is kind of a weak area even today for Android. Heap bugs are really hard to kind of fix or mitigate away like magic. Yeah, so Android's mitigations did come into play though when I tried to exploit it. Although I think properties within the system were often more of the challenge than the mitigations themselves. So a quick recap about Media Server. It's always spawning automatically after you crash it. The ASLR weakness that Zygote has, if you're not familiar with that, Zygote process forks other processes off itself, all apps that run, including system server, forks itself and just creates those without doing any sort of exec syscall. So that means the address space between all things coming from Zygote are the same as what Zygote's address space is. So if you have an app that's totally like, I only want internet permission, and it has some JNI or something, some native code inside of it that looks at its own address space, that's going to be the same as system server, which is running with like, you know, almost the highest privileges you can get on Android. Possible to retry forever. So even if we're just crashy, 1 in 256, you will win if you just keep trying. Definitely. It's and so it's possible to bypass ASLR even through sheer brute force without any sort of magical tricks. You could have a really crappy exploit, and it would still eventually land, probably, unless it was really crappy exploit. So the thing is, on the downside is that, well, I have a plus here. You're always thinking with both hats, the bad guy and the good guy. So in this case, this is a plus for the good guy side. There's less determinism in Android because all processes have lots of threads that are waiting for stuff going on. So there was actually a new mitigation added to Android 5.0. Funny story, they did not know they added this mitigation to Android 5.0 and later. But it's cool. So they changed the heap implementation to jduck in 5.0 as well, from dlmalloc, which it had been for many years. But they also included this new integer overflow mitigation that came in with GCC 5.0. So I guess they were thinking, you know, the build teams like, oh, GCC 5.0, that's cool. We're going to be Android 5.0, so let's just all be 5.0. So they put it in there, and you know, come to find out, it prevents entirely exploitation of some of the bugs. Definitely not all of them, but some of them. So here's like a summary of how mitigations play, and I should update this slide. Stack cookies, they don't matter, we're on the heap. You know, fortify source, oh well, fortify source doesn't really work if it's a dynamically allocated piece of memory. It has no idea how big it should be, so it can't tell you when you override it, past the bounds, you know. ASLR, well, ASLR wasn't there for a long time, not properly at least, and it comes to find out that ASLR actually isn't really a big help anyway. Well, and of course NX is there, but you can just wrap around that. It's cool. Wrap around the clock. And the new mitigation definitely, like I said, fixes some of the bugs, makes them unexploitable. If you trigger them, you know, you can still trigger them, but it turns them from heap memory corruption into a denial of service, where it's just like, I cannot allocate 4 gigs of memory. Are you fucking kidding me? I mean, like, it goes, this is going to overflow, and then it sets to maxint, and then, yeah, that never works. Maxint malallocations never work. Yeah. So I should update this slide, I say, because SE Linux, when I was doing the exploitation, it was on 4.0 just because I thought it'd be easy mode. Turns out 5.x is easier. That's too bad. But SE Linux does come into play on 5.x. It's always enforcing on Android at that point. So I got a shell in media, well, I got code execution in media server on 5.0, and I'm like, let's just run the shell. And it's like, no, you cannot execute a shell. Oh, boo. And I was like, well, I'll just bring my own shell in, right? And then I was like, wait, if I bring my own shell in, that's great, I get a shell, but whenever I try to do anything in the shell, it tells me you cannot execute anything. So that's worthless. But it does come into play. You know, I say NA here, but the NA is basically after you have code execution, then you start hitting the limit of SE Linux. So it's definitely not like, it definitely would never stop you from streaming the audio of the microphone out to yourself. Like, they can't, because this process is literally intended to do that in some cases. So they cannot lock it down like that. Address layout randomization. The big bypass, it's shocker, 32-bit address space, heap spray, yes. One very large thing. Very large, can't split it up, it's one, so a lot of address space you control right away. I don't even know why I got other virtual memory tricks on there, because I didn't need any of those really. Brute force statistical guessing, you know, like the Adrian Ludwig from Android security team, he's like, yeah, we're interested in like ASLR bypasses that are not based on statistics. And I'm like, okay, but an attacker is going to go for whatever's easiest, and that's like, see what happens and then pick the cool one, you know. You can try 10 times, and if like one of the numbers comes up 5, you're going to be like, that's the number for me, you know, like I don't want these other ones that are not the same, you know, the big one. And that's totally my approach to some of the bypasses in ASLR that I've done there. So a little bit of recap on ASLR, like, you know, 2.3, there's no ASLR really at all. It's hilarious because they had the support for ASLR in the kernel in 2.3, but they were building the binaries without the flag that says I want to be randomized. And then Ice Cream Sandwich, they added some ASLR. They finally started using the right compiler flags or the right compiler. but it's still weak, meaning without full randomization, you basically have no randomization. So in theory, ASLR was a big deal on these other things, and it turns out like, Jelly Bean and Kit Kat, the ASLR is actually like more effective than in Lollipop. That's lessons learned from then to now. So you guys want to like try to do a live demo, or didn't I have a like bag somewhere? So it's 10? Let's see if this phone still works. John, can you do a demo faster than me? No? Okay. It's booting up. It's kind of like lame. Maybe I should just wander around and spray shells all over the place instead, because I don't have any way to show you this in a good way, really. I can play the video, which is like a little bit easy mode. Oh yeah, so let's do the F button again. No? How about escape? Escape works. It's still, it's up. Let me see if I can turn on our radio here. Airplane mode is now off. Where on earth is my cursor? There it is. So we can play this video while we're waiting. Let's do that. See if I can get this thing to work live. Here, I don't know. We got no audio. Plug her in. Phone over there. You see the phone down there? Let's try it live. Where do slides go? Oh, while we're here, we might as well play the cat video, right? Can you imagine hearing that every 1 second from several phones? Yes. Yes. Fuzz the things. All right. I had to put this down because I think I got to type a little more before I can actually do some kind of demo. Pull out another phone, do something on that one. So there's a little bit of slides here at the end of in the bonus slides that explain how this demo worked. Basically, in the video, you see me sending MMSs to myself, which is true. However, I'm not sending them over to carrier network because I feel like that would probably get me banned the fuck off of all the carrier networks. So I don't do that. Instead, I built this. I actually had spent like a week and a half or 2 weeks developing this whole thing where it's like I want it to look exactly like it's supposed to look when it comes from the carrier network, but I want it to come from me and not go over to the carrier network at all. But there's no requirement for that. Like the exploit doesn't depend on me being in the simulation environment. It just helps for the demo purpose, for the video and so on. Let's see, do I have a window somewhere with like hackering in it? Is that the hackery window? Come on. There we go. I'll bring it over here. What do we got? I may not even have the exploit on this machine. What directory am I in? What machine am I on? What's going on here? This is literally the worst angle ever to see your screen. Yeah, I don't have it. So that's going to make it a little harder. So what I'll do instead will be a little bit more fun, I guess. Yeah, so I will try to set up the demo and wander around with it today. But for now, what we'll do is we'll run a different exploit, the 5.x exploit. I can type my own password still, isn't that awesome? All right. Oh, fail. You guys probably could not see that in the back, can you? Can you see it in the back? Can you read that? Griff, can you read it? Yeah. Should I make it a little bit bigger anyway? Better? I always got mail, man. That's how that goes. It's not always stuff I want, but it's always there. Oh, what the fuck? What is that? So, what? This is on the device here. We can run Logcat for fun. Oh, you saw there's some crashes already going on here. Let's turn on my screen on my phone on my desk at home. Isn't that awesome? Oh no, internet fail. There we go. There we go. Let's see if this works. It may not. Oh, yep, it won't right now because I've got to turn Wi-Fi back on the device. So let's do SU service Wi-Fi enabled. Maybe. Yes? Yes. Come on, do it. Come on, do it. I don't know what's going on. Oh, what happened? Oh, a request came in. Yay, a request. You'll notice that they're not very shy in the browser on Android. They're just kind of like, here's my butthole. Yeah, I know Android, it's all that, like, oh my God, fragmentation and diversity, it so saves you, but like, oh, by the way, here's the exact version of the firmware I've got and everything else. Come on, do it. That isn't even scrolling. It's not scrolling anymore, right? What the hell's going on? That does not look like a shell to me. It's kind of slow today, huh? It's probably the internet, not the exploit. Wow, it's taking longer than it ever has taken before. I'm going to come watch with you guys now. I don't even do it. You want to literally everything is wrong. So I think that's really wrong. But it is trying still to own itself there. But we can do the logcat and see what's going on real quick before I get my ass booted off stage. Did anybody see anything crash yet? Yeah, this does not look good. It's not crashing anything even. Permission denial. What is this shit? Wow. So never do a live demo. I bet if we reboot the device, it'll work afterwards. Exit. Did I not type an exit right? A to B reboot. Did we get a shell in the meantime? Just to like, whoops. No, we didn't, did we? Yeah, it was not crashing anything, which is a very bad sign for trying to exploit Stagefright in this case. Oh, it's back up again. I think we should wait a little bit because phones don't really like it that much when you go to town on them right when they first wake up. And besides, it's not really a realistic sort of attack scenario where it's going to be booting while you attack somebody. That looks good. Let's try again. Come on, make some requests. Yeah, maybe they did some other modification to the system to prevent it from the browser, which would be awesome. I have not seen it crash yet. It's not even trying to like make the request. What the fuck? How much longer do I have to fail at this demo? A minute past? Yeah. Well, you guys, I won't be offended if you leave, but I'm going to try it for another minute maybe. You know what? I'll go back to the slides for a minute and get this shit. I'm really upset because that was totally working yesterday. Brian can vouch for that. So, you know, now I have to figure out why it doesn't work. Wrong window. One of these has slides in it. Can you guys tell me which one? This one. All right, and then we'll F it again. F it. All right, so demo fail. You guys did see the video, though. That worked. What about getting it fixed, right? So I reported it to the Android guys with patches. So I was basically like, at the time they had no bounty program, and the closest thing they had was what's called a patch rewards program. So I was like, okay, that means in order to get even any chance of any money, I have to send patches, which is like, okay, that's fine. I would generate patches anyway, so why not? So I sent them a first set in April. You know, I told them, hey, check this stuff out. These are fixed critical remotes. And they're like, we'll offer you $1,000. And I'm like, wow. I thought it was going to be 20 or something, but okay, one. Okay. I'm going to McDonald's. Going to McDonald's. And then, you know, I tried to work my magic. Like, you guys should really care about this. This should clearly be important. You know, it's critical remote, like, without any interaction, like you could own, like, you know, exploits from the old day when, you know, people had really bad server code. Anyway, I could only convince them to raise it to $1,337. That's really all I asked for. I was like, you know, can you at least recognize the quality and importance of the work with a fancy number? You know, and they were like, yeah, okay. There was no pushback on that. It was totally like, done. So I did it, and then, you know, I did it in two kind of sets of patches. And because of that, I gave them extra time on the first set of patches. You know, the idea was to have this all fixed before Black Hat, because Black Hat was where even I could not avoid publishing it without, you know, being a dick. I don't want to do that. Not to Black Hat. not to pretty much anyone. So also reported them to Mozilla, who has a bug bounty program. Yeah. And to Blackphone, Silent Circle, through Bugcrowd, who they also have a bug bounty program. So although people think like I only made like $1,000 total off of all this thing, because that's all the media wanted to, key in on, it's actually more like around $7,500. So I have some bug bounty money. If you guys want some drinks, come let me know. I have this pact, which is like any money that comes from bug bounties, it's just kind of automatically spent on making sure everybody has a good time. And I keep track of that. So, but right now there's more bug bounty money than people drinking on it. So, hey. So I requested embargo from everyone. I was like, hey, 90 days is kind of when I want to coordinatedly go public with everybody. So then Mozilla immediately proceeded to like commit a fix to their tree, and I was like, oh shit, you guys, what does embargo mean to you guys? What does it mean? And they were like, well, for us, embargo means we won't publish a public advisory. Oh, okay, well, it's too late now. That's not what it means to me. Yeah, we had a heated discussion, and I think at one point we had both offended each other and then talked each other back down to sanity. I think they threatened me and I threatened them a little bit, and yeah, it got kind of ugly. But anyway, like they were like, next time just request a no code push embargo or something like that. I'm like, oh, how the fuck am I supposed to know the difference? But okay, so for your guys' sake, if you want them to not publish the fix for your stuff, like ask them not to specifically not do that. And just to prove I'm not an asshole, like I was totally cool with them publishing the fix in binary form. I'm totally cool with Blackphone publishing the fix in binary form, because if you're reverse engineering patches, like, good for you. That's tiring and wild work. But not a lot of people do that, especially bad guys, because again, it's hard work. So everyone was great to work with, even though, like I mentioned, the little bit of spat with the Firefox guys over the embargo thing. Everything's good now. In August, they rolled OTAs, basically the day I went on stage at Black Hat, and they had kind things to say, including they said, hey, all the top OEMs have today just committed to fixing these bugs on all the stuff. And they showed like a slide with all of like the, what's the word? Flagship devices, including like previous generations. So as far as how well they've delivered on that today, I don't know if it's really acceptable how well they've delivered, but they're trying. They're definitely trying. The Android guys accepted the code patches I sent them like pretty much immediately. They were like, bam. I think the first time it was 1 day, and the second time it was like 3 days. And that's probably because I sent it on a Friday or something asshole thing to do. Not on purpose, of course, but just because that's when I got it done. And so, both times they're like, hey, thank you very much for the patches. And this is a totally different guy than the $1,000 guy, of course. But, they were very, very appreciative. They were like, thank you very much for helping us make Android more secure. And this is before they had a bounty program, but like it was still good stuff. Mozilla fixed it in 38, like I said, pushed it right away. The guy there is a maniac. The media guy there, he's a maniac, but a maniac in a good way. So actually, I did all these patches and sent them all to Google, right? And the Firefox fix was like in 2 spots. And it fixed all of the bugs that I had reported to Google. So it's just a difference in choices. And at this point, their fork is so different, they can't even merge anymore. So we also created the ZHA real quick there. When we blew up, we were like, hey, we want to give people more access. And I think it's actually persuaded the Android security team to be a little more liberal with who they allow to have access to OHA bulletins, which if you're not familiar, that's basically like what they're doing now. Monthly is a public security bulletin for Nexus devices. And basically that report is the same sort of report they would send like 30 days earlier to the OHA partners. So one thing what I noticed when doing this work was, for example, Amazon was not given access to the stuff that I sent to the Android security team. So I had to like reach out to them directly. Same thing with Blackphone. That's the reason why I hit their bug bounty program, was because Google didn't tell Blackphone about any vulns at all that they were getting reported to. getting reported to them. So we're still running the ZHA, although now they're a little more liberal, so it's a little bit less of an important thing to do. So update deployment, this slide I haven't changed it, but it's hilarious because I don't actually need to change it. It's still happening. The updates are still rolling out. Some people haven't got one ever still. Some people never will, and I'm really sorry for you guys. You might want to throw anything that's not going to get an update in the trash. Or send it to me, I'll put it in the Droid Army. But anyway, so there's a long tail, man. I don't know if I have the diagram up right now. I know I'm way over time, but nobody's kicking me out yet.
It's the lunch hour, so you're good.
Huh?
It's the lunch hour, so you're good.
Is it lunch hour? Shit. Well, again, I won't be mad if anybody leaves. One of these windows, I thought, had it in there. I don't think I'm going to find it that easy. This angle in the screen is too much. All right, so now they're doing the 30-day patch cycle, and we've seen them make good on this both in September and in August. So they're definitely committed to doing it, and they are doing it. So that's awesome. You guys should probably expect to maybe get another update with something about Stagefright, maybe like next week or the week after. I think they are posting these Nexus bulletins like first Monday of the month or something to that extent. So at the same time, they'll roll the OTA updates, push all the code to AOSP. So be ready for more updates and hopefully not too much more pointless media buzz. So if you get an update, it's probably these. And in fact, that's been the case for the last 2 updates and probably will be at least for 1 more. So Android code needs more attention. There's tons of code. More people need to look. Google clearly is not looking or even paying anyone to look. So yeah, somebody should do that, and why not you? Fuzz some stuff. Fuzzing is fun. At least you get to see things blow up at the very least. Another important point from all this research is that mitigations are not a silver bullet. You can say, well, ASLR is going to fix that. Well, unless you actually try to see if ASLR really does fix that or stop that, you don't know. And with something that automatically restarts forever, ASLR is never going to be your thing that you care about. Like, it's never going to be the thing that stops it. It's just going to take a little bit longer. So people need to be more proactive, and they actually are starting to do that. So I'm really happy about that. I don't really have any more slides other than all these bonus slides, like tons of them, but I don't want to go through those now. I would rather eat lunch. But you can go through them later. Does anybody have a question? I'd love questions.